Okay, so today we're talking about op-amp differential amplifier. Okay, they get a three terminal input, minus side, and non-inverting input, plus side. That's what they're talking about here. Input positive, input negative, and the one output. And they need to power supply ranging from plus minus 8 volt to plus minus 38 volt. And in the left volt, normally we're using 15 volt and minus 15 volt. Okay. For the ideal op-amp, open loop gain will be infinitive. That's what they show you here. Input impedance, infinitive, or output impedance equal 0. Okay, that's what we're talking about. Ideal op-amp representation. So when you're looking into the op-amp, one of the things you have to recognize which one is positive input with the name in non-inverted, and the one with the negative input that will be inverted. And what is the VD? Different voltage between positive input and a negative input, and they want it to be 0. That's only telling you V at positive and V at the negative input will be the same. Okay? Okay, now this is the one IC op-amp we using in the left volt. Okay, they get input positive, negative, and the output. Okay, and what pin for power supply. Okay, so practical op-amp, high voltage gain, AV, very high input impedance, very low output impedance, and a wide bandwidth.
Is that your computer, Mr. Pham, or something where it says low battery?
That's what a problem. Okay, so I have to change that into
Yeah, you just got to connect it to the charger. That's all.
What? Can you say again?
Yeah, just connect it to the charger.
I connect in the charger, but they're not.
Oh, all right, I'm sorry.
They're not charging at all. They keep going down. Something wrong with the iPad or whatever. Okay, so now I will be stop that guy. Okay, and I using the
We're going to have to take up a collection, Mr. Pham, and get you a new iPad.
okay. Just a minute.
Donations.
That's the problem. Just a minute, okay?
Okay.
Let's see. Okay. So now I have to using my computer, and I try to see I can solve the problem for the iPad later. Maybe have to get another one. I don't know. Okay. So now you can see it. Okay. You see the display, right?
Nothing showing.
I don't see the display.
Uh-uh.
All I see is your name.
Okay. I know. I know what is going on now. You see it now?
Yes, I see it.
Okay. Thank you. Okay, basically this one, IC 741, that's the op-amp. Okay, you will be working at the level. Okay, and now for practical op-amp, you get input negative inverted, positive will be non-inverted, and VD, the difference between positive input, negative input, and they're supposed to be equal. Okay, for practical op-amp, they want high voltage gain, very low, very high input impedance, and very low output impedance, and the bandwidth will be wider. Okay, now practical op-amp output voltage Vout equal Vs positive Vin at positive minus Vin at negative time open loop gain A, that's for the gain, OL, upper open loop gain. And that you already know. V in plus minus V in minus, that will be VD. Okay? VD times the gain. VD, difference between two input, okay, and the gain, AOL, open loop gain, for 741 low to 200,000. The output of amp is never higher than power supply. Okay, you can see the gain very high, 200,000. However, they're telling you, okay, output of the op amp never higher than power supply voltage. Okay, we're using the power supply voltage in the left phone for op amp plus 15 volt on and minus 15 volt. Okay, when input apply is too high, that force the op amp into saturation. And the op amp output will be equal plus or minus saturation voltage less than power supply around 1.4 volt. Okay. Open loop gain AOL is defined as the amplified output amplification without external feedback signal connect to it. And for a typical operational amplifier, is about 100 decibel at DC. That means frequency is 0. Now, try to set this one. An op amp has open loop gain 200,000 with a power supply plus 15 and minus 15 volt. And also the given out V saturation equal plus or minus 15 volt. That means they don't care about the difference between 1.4 volt. Complete the VD and V out in the following table. Number 1, you get 20 microvolt positive input, 40 microvolt negative input. What VD equal?
20 microvolts.
Okay, just a minute, okay. I want to be using this one. So that one we can write down. Okay. So what the value here? VD.
It should be 20 microvolts,
Minus
I
or
think.
is it minus, right?
You need to open your screen at the bottom, Mr. Pham, so we can see that formula. Yeah, there you go. So VD is it's going to be the plus input minus the minus input. So it's going to be 20 minus
So it's negative 20.
40.
Minus 20.
And then that'll be times the 200,000 for the V out, the AOL.
So number 1, okay? VD equal 20 minus 40 equal minus 20 microvolt. Okay, I try to make it bigger. Okay. So what VD equal?
Minus 20 microvolts.
VD equal the gate time VD. Okay. That means VD. Okay. Time AOL. Okay. And VD equal, no, VD, let's see, VD equal V, what that mean? V what? VD, right?
Hey, Mr. Pham, that white screen you're writing on is covering part of the, you need to move it to the right a little bit.
Move to the right.
Yeah. Move that big white screen to the right. Yeah, there you go.
Okay, V out.
E out is AOL times VD.
Okay,
And the AOL is up top in blue where it says
200,000.
200,000.
VD mean minus 40. Half, 200,000. Equal what?
Isn't it supposed to be negative 20 microvolts, minus 20 microvolts? Isn't that the VD?
No, right now, we're looking for VL. VL equal
VD
VD,
times AOL, right?
right, 20, minus 20. Correct?
It should be negative 4 million. The V out should be negative 4 million or minus 4 million.
Okay. That will be a 20 micro. Okay. So 2 times joule mean 4, right?
Yes.
Okay, let's see. 20 times equal divide 1 million. Is it minus 4 volt? That means VL minus 4 volt. Now, you can go ahead and do for me number 2.
When doing these problems, are we supposed to be converting it always to volts and not microvolts?
No, yeah, that means not microphone have to be in volt.
Okay.
I won only VD. And VL. Okay, what VD?
minus 50.
Come on, what VD? Who got VD for?
Minus 50, 50, minus 50 micro.
Who else?
I got the same answer, minus 50
How, man?
microvolts.
I got 70.
Oh yeah, it's minus the plus. Yeah, so it's 10, which is plus, then minus a minus 60. Minus a minus is a plus, so 60 becomes plus and 10 becomes 70. That's right. I forgot about the minus sign.
You get a 10 minus to minus 60.
Right, right.
Okay?
Okay.
And what VL?
70 microvolts times 200,000.
Yeah.
Should be 14 minus 14 volts. Never mind. I think I'm wrong. Sorry. No, yeah, I think it's negative minus 14 volts.
Is it 14 VL?
Yeah, yeah. I got 14 million microvolts. So that would be, yeah. Is not minus or got it. Never mind.
Okay? Number 3. VD.
You got minus 50 microvolts minus a minus 30. Minus is a plus for the 30. So 30 from 50 is 20, and 50 is a higher number. So it's minus 20 is VD.
Is it minus 4 volt or what? What you get? Number 4.
Hey, Mr. Pham, first of all, on number 4 for VD, you got 20 minus a minus 120, correct?
Right.
So then minus a minus the plus. So 120 and 20. Oh, you got 140. Yeah.
So what VL equal?
140 times 200,000. I don't have my calculator. Sorry, Mr. Pham, I do not have my calculator. Yeah, but in any case, V out is 140 microvolts times 200,000.
Correct. Who give me the answer?
Whoever got a calculator.
What was it? The numbers? I'm sorry, 140 times 200,000, right?
Correct.
Microvolts,
Correct.
140 volts. Okay. I have 28 volts.
Okay. Now, that correct number. However, we already know output of amp cannot be higher than power supply, 15 volt.
Plus or minus 15, right?
Yeah, either one. So they cannot equal 28 volt. So the op amp already saturated. Okay?
So the max it can be is, since it's a plus voltage, the max it could be would be 15 volts, right?
Exactly. Not. Okay?
28 is the right answer by the mathematics that we did, but the rule says that can only be plus or minus 15.
Okay? So the answer will be they cannot be 28 volt. Op amp already saturated. So when they saturated, either they can be equal positive saturation or negative saturation. In this case, they will be equal 15 volt saturation.
So I have a question.
Yeah,
So is this like how when I put something into the outlet and I don't know, maybe it's too strong, and then say instead of it producing 28 volts, it produces 15 because it's safe? Is that how the op amp works?
right. They already telling you op amp cannot be higher than the power supply. And in this case, the power supply plus and minus 15 volt. Now you calculate the VO 28 volt. That's only telling you op amp already be saturated. And when they saturated, then the output they can be either equal positive saturation or negative saturation. In this case, V saturation they're using plus or minus 15 volt. That's telling you V out will be equal plus V saturation.
Okay.
If I could ask the gentleman who just spoke, was he asking, do the op amp automatically go to 15 volts if 28 is too high? Is that what you were asking?
You never say
Yeah.
28.
Yeah, that was what I was asking.
Okay, yeah.
Number 5. minus 100 minus 45. That means minus 145.
That's minus 145 microvolts times 200,000.
It's minus 29 volts, but that's not. So it's minus 15 volt saturation.
Perfect.
Right. All right.
So you say they will be minus 29, right?
Yes.
Okay. Not supposed to be. Okay. And they will be minus 15 volts. Yeah, look like you guys understand now. Okay, number 6. VD. Let's see, 110 minus 45.
So that like 65 or something?
65. So you forget your calculator or you don't have it.
It's somewhere in the house that I can't find it. I'll find it later on, Mr. Pham.
Yeah.
It's 65. Yeah.
So we out.
It's 13 volts.
13 volt. No problem.
Are there like any real life examples you could use so I could understand just a little bit? Like, when do we use these applications? Like, is it on certain parts of circuits? Is it like, when do I know that I need to learn how to use an op amp?
Okay. Basically, when you're working on op amp, you have to know power supply, voltage, and also the saturation voltage. In this example, they make more simple. So that's why they given saturation almost the same like power supply. Not big deal. Okay. Number 7.
Hey, Mr. Pham, I know the question that he just asked, but is it true that you get to see how the op amp work better in Tech 2 than Tech 1?
This doesn't matter. They have to be the same thing.
Oh,
Take 2 or take 1. If you deal with the op amp, same thing. That
okay,
that electronic take 2 only digital.
right.
Okay, 7 minus 25 plus 25. Is it 100?
Yeah, it's 100. It's minus 100.
What
Or
we are?
I think. Uh,
I was thinking the same thing. Is that minus 100?
I'm not sure. I did
Seven
negative 25 minus.
minus 100.
Okay.
Yeah, minus
And it
100.
should be minus 20 volts.
That will be not, right?
Right. Because minus 20 is bigger than minus 15.
So they will be
Minus
plus
15.
15 V saturation. Okay, last one.
So minus the plus. So would that be minus 40?
Minus 40. V out.
Times 200,000.
Is it 8 volt or what? Minus 8 volt.
Minus 8
Yeah,
volts.
yeah. Okay. So if you can understand this example, no big deal when you're working on the assignment. Okay, any question?
So if you're working on, say, the lab volt or whatever on the op amp and you get that big voltage like something over 15 or under negative 15, you take and dial back on your supply voltage?
That depending on what they given power supply and what they given saturation.
Okay.
Okay, now input signal mode 14 single-ended mode. You can see they get you input, but they apply only one to the negative and positive ground. Okay, input apply to either positive or negative of amp, and the other input connect to the ground. Okay, so that's given to you. This one they apply input to the negative. This one they apply input positive. Okay, and now in a common mode to signal. Okay, apply into one go to the negative input, the other one go to the positive input. Only thing they make sure you understand they must be opposite. That means if this going up, this has to be going down 180 degrees different. That's only thing they emphasize. Okay, to make sure you understand that. If you get the same signal, both going up or both going down, that's considered to be the unwanted signal. That means the noise that will be already talking to you. on the first of the op-amp lecture. Okay, this is the operation amplifier. The first one. Okay, input offset voltage. The ideal op-amp produces 0 volt output for 0 volt input. If you get input 0, output will be 0. However, a small DC voltage Vout error appear at the output when no differential input voltage is applied. So its primary cause is a slight mismatch of the base. Emitter voltage of the different amplified input stay up and op-amp as specified on an op-amp data sheet. The input offset voltage VOS is the different DC voltage required between the input to the force. Okay, the output 0 voltage. Now, this is the op-amp. Input negative, input positive. If you connect both input to the ground, output supposed to be 0. However, sometimes output they get 10 millivolt. That's what we're talking about. Offset voltage. Input 0, output must be 0, but they're not 0. Okay? So you get a 10 millivolt, for example. And now, what they have to do, they connect pin 1 and pin 5 to the variable resistor, 10 kilo ohm. Okay? And they adjust the resistor until output 0. That adjust for 0 output. Okay? You have to know that one. When you do a left on, you have to do it. The purpose A, input 0, output 0. If the output not 0, you get an offset voltage. And this is why you have to make a connection to adjust until output is 0. Here, more explanation. Adjust offset voltage. Connect the port to pin 1 and 5. Connect both input op-amp to the ground. Adjust the port until Vout close to 0. Okay? That is the process to adjust the offset voltage. Next one, open loop and closed loop amplifier. This is open loop. Okay? They not connect anywhere. AOL equal VL divided VE. And now, this is really the one you're working on. Closed loop. This for inverting amplifier. Okay? So they connect output back into the input with the resistor RF. RF means feedback resistor and connect to R in and to V in. Okay? When you go into this circuitry, you can see they get a closed loop gain equal minus RF over RI.
And we know it's inverting because the signal is going into the minus.
Right.
And then the resistor, the feed, and then for closed loop gain, you got to have a feedback resistor.
That's what the name.
Okay.
When we go to inverting amplify. Okay. Now, a lot of people not quite understand on this display. This stands for the gain. A for the gain. Okay. This side stands for the frequency. Okay. So when they get the frequency is 0 here. Okay. And the gain maximum will be 100 decibel dB. Okay. And when you go into 3 dB point, what that means? At the frequency equal 10 power 1 mean 10 hertz. Okay. And they start going down. That means the gain keep going down. Okay. To this 10 power of 6. Okay. In here. So if you at this point, then you can see what frequency you going down. 10 power of 3 means 1,000. Okay. 1,000 hertz, 1 kilo. And you looking into the left, you get the gain now go down to 60 dB. Okay. So slope, they say, they will be going down 20 dB per decade. That means if you going down 20 dB, okay, at this point, for example, okay, this point you got up to frequency 10,000, and you go to the left, the gain going down. However, they only bring up to you one thing. When you want the gain less than maximum, that means the frequency will be increased. Okay? Frequency keep increment. Okay? Then the gain have to be going down. Now, next one, you get inverting operation amplifier. They connect this way. Output connect back to the input. Okay. That will be called RF, feedback resistor. Okay. And they connect to in, and they connect to the input. The other positive input connect to the ground. Okay. 14. The point here at the V2. We already telling you. That will be a virtual route. Okay? Virtual route. So V1, V2 V different. So my question is, at this point, what the voltage?
V1 and V2 are the same, aren't they?
What the voltage? At this point, X right here,
Oh, because it's 0 volts?
0 volt.
Because V1 and V2 is the same. So if V1 is 0, then V2's got to be 0.
Exactly. The thing is V different is 0, right?
Right.
That means no difference between V1 and V2. However, the point I care to go a virtual route. The difference will be, okay, now you see the current I in go to here, go to this point. Where they go?
Up.
Why they not go down?
Well, it can't go into the op amp because you have a high input impedance anyway.
Okay, you say right. They cannot go to the op amp, high input impedance. However, my question is, they not going down, right?
Right.
Why they not going down?
There's no connection going down. That space there is that's just to show that it's a virtual ground, but it's no connection.
No, they not going down. The thing is, they get the same potential,
Oh yeah.
0, 0, right?
Right.
Okay, so the input going this way, go up and go to F and go up to here. Okay, and now they try to explain to you. RF feedback resistor. Okay, between output input produce closed loop gain ACL. Okay, A mean gain, CL closed loop, no current flow into the input terminal. Region A, high input impedance. The differential input is 0. VD equal V1 minus V2 0. That's telling you V1, V2 the same. Closed loop gain equal minus RF over R in. RF here, R in here.
So I just have a question.
Yes.
Does this mean it's operating like an open switch when because it has so much high input impedance? It's like an open switch now because it goes around the amplifier, the closed loop. I don't know if I'm understanding this correctly.
Okay, they not get any switch in here. Okay, if you connect circuitry this way, I can tell you the current go into through R in and go to route, right? The thing is, input 1 route, input 2 will be route. So this current flow to the point here. They cannot go into op amp, high input impedance. They cannot going down, same potential. but the potential difference between V2 here, V1 here, V2 here, not the, basically they routed, but they get a virtual route. So that's why the current go to that point. They have to go up, okay? Go up to RF and go to the output here, okay? So they already telling you, if you want to calculate the gain of this inverting, they will be minus RF over Rin, okay?
Okay.
Okay, now, that's what they call a virtual route. See that? They draw the current flowing here, and they going up here. When they go into IF, that positive, the other side negative, and the other side connect to the output, so this negative and this will be negative. Okay? And for the load, if this side negative, the other side must be positive. So the current going down here to this point, they cannot going down. Why? The other side of the load positive. So that's why they have to go into the op amp. That's what they call sink current. Okay? Op amp pull in the current inside. Okay? And also, you can get the one side of the load port 0, the other side negative, so you get the IL, load current. So the load current go into VL, they also go inside. And try to see the explain to you here. Current I. If you want to calculate the current I here, you know this side is ground, this side is power. So you take the power divide R1, you get the current I. Okay? See that? Current I equal V in divide R1. 5 volt divide 1K. You get 5 milliamp. And the closed loop gain equal minus R1, R2 divide R1. Basically RF divide R1 equal minus 1.5 K divide 1K. The gain will be minus 1.5. And you want to calculate the V out. You take the gain times V in, given you minus 7.5 volt. And the load current IL equal 0 minus to minus 7.5 divide 5K. You get 1.5 milliamp. And now you want to calculate the total current. I out equal I plus IL. That given you 6.5 milliamp. Okay? In the circuitry, make sure you know VD equal 0. That is a completely analyzed for inverting amplifier. Okay, any question on this one? You know, that's what the name will be, inverting amplifier. The reason is input applied to negative, inverting. And if you're looking on this circuitry, okay, you have to know how the current flow. Current I go here, going up, go to IF, and going down to this point. Go into the op-amp. Op-amp sink current, put the current in. Okay, not the app current I. Also, you can get the current from load IL also coming in. So you're adding two current, you get the total current of the op-amp. Okay, so basically you can get sink current. Op-amp pull the current in. And next one you can get a source current. Op-amp send the current out. That will be a very, very basic for either technician or engineering. Okay, you have to be understand. Let's see what else here. Okay, so basically, example here. I want you to calculate for me. Number one, gain ACL.
Is the gain R3 over R2?
Equal
I'm asking you, Mr. Pham, is the gain R3 over R2?
10K divide 1K.
Yeah, so the gain is 10.
So now this coming out from left volt. Okay, and they want V out.
The first one is the gain, ACL, right?
You know V out equal minus, right? ACL, right?
Mm-hmm.
Time V in. That was minus 10 time. What V in?
1 volt.
Number three, current I. 1 volt,
1 volt divided by 1K.
1K equal 1
Milliamp.
milliamp, right?
Mm-hmm.
Okay. Number four, IL.
IL, was that the current through R5?
Exactly. Equal 0 minus divide one milliamp, right?
Okay. But go ahead, finish writing. I got a question after you write. Okay, Mr. Pham. So the zero is because that comes from ground, correct?
Right,
And then the minus 10 volts, that's the minus
10,
minus 10 V out.
right. We out here minus 10. Okay. However, if you want to calculate the current, you have to find a different voltage between one side positive 10K and one side negative 10K. That's why they say 0 here, minus to minus 10 here, divide 10K, you get 1 milliamp. Okay. And op-amp current, I out equal I plus IL. So 1 milliamp plus 1 milliamp.
2 million. Okay.
Okay, when you understand op-amp you're working on, left phone will be no problem. Op-amp look like more easier than transistor. Okay, so any question, anything up until this point? No question. Okay, so I will stop here. Okay, I will be try to working with my lab, you know, the one they could run out of the power supply. Okay, iPad. When you teaching using iPad, that will be more easy for your guy to follow it. Okay? Any question? Anything?
Thank you very much, Mr. Pham. Have a good weekend.
You too. Okay? And hope everyone, okay, you have a good weekend. Okay?
All right, thank you. Have a good night. Have a good weekend.
Good night. Okay?
Happy
Thank you.
Halloween.
Thank you, your guy.